Good morning everyone. Myself Aashish, software engineer at GeekyAnts. Today I am going to present you about concurrent mode in React. So currently it is an experimental feature. So let's start with the presentation. So before starting, we should first understand what are the problems that React developers are currently facing. So first thing is rendering in React is blocking. It means we have to wait for the previous render to finish to start the new one. Second one is we use a fetch or render approach which create a problem of waterfall. It means that firstly we wait for the components to get loaded, then we start load the data. So currently it creates the problem of waterfall. So third thing is in every React app we use lots of API which are asynchronous in nature. So what we have to handle the loading states by using states and promises, which is lot of boilerplate. So we have to repeat it again and again. So we will handle this problem using Suspense later. And last problem that I think important is we generally notice UI flickering in React. Suppose you are on a very fast connection and you transition from one page to other. So I think you will see loader for around 200 milliseconds, which is a very small interval, and it causes problem of flickering. So let's start what is concurrent mode. So as we have talked, the FB team is using concurrent mode for around 1 year for their code base in production. But still it is a very confusing issue. Still a lot of developers don't know what concurrent mode is. So we will cover all the basics of concurrent mode, and after that talk I think that we will able to clearly map what concurrent mode is. So the basic concept that differ normal mode of React and concurrent mode is in normal React what we do is normal rendering. Normal rendering means we have to wait for the previous render to finish, then we start the new render. So let's see the example. Here we have typed some input and corresponding the data points are increasing. You can see that at some point if you type the input very fast, so the input will get hanged, and you can see that it will come here after some time. So what happens is our thread get blocked and the input, we are not able to see the user input. So we will see how we can handle it. So currently React introduce the concept of interruptible rendering. So what it does is, suppose that the data or component get rendered, is rendering, and when a user click an action, so what happens is React will stop the previous render and start to process the user event. After the user event get completed, React will render the remaining part. So I think you will able to understand it. So let's understand it in some non-technical way. Let's see two players are playing TT and they are in between their game. So other two players come which have some urgent work. So they told that, so we want to play the game. So currently in the previous version of React what happens is we have to wait for the first players to finish their game, then we can play our game. But in concurrent version of React, the other player will wait for us and we can interrupt them and we can play our game, then after that they can continue with their game. Okay, so this is the concept of interruptible rendering which is introduced in concurrent mode. Let's see the example over here. Here you can see that when user types, he can see the effect at the instant. He should not have to wait for the inputs to get data to get rendered and then see the result. Firstly we'll see the user action and then the rendering is happen after that. So let's see what are some of the features that React currently introducing. So React introduces data fetching with Suspense, and second one is Suspense list, and the last one is transitions. So let's start with data fetching with Suspense. So currently it works as render as you fetch mechanism. It means we will not have to wait for the data to get loaded, then do the fetching call. We will do both of them in parallel. So you can see here in the diagram that here the loading of the component is started, and parallelly loading of the data is also started. So it can improve the performance of our app. So it will improve the runtime of our app. So it will also help in avoiding the problem of waterfall, which we face in the normal React. Okay, let's see it in the code example. Here you can see that we have wrapped it in a suspense component. We have wrapped a my suspense image component in a suspense component. Suspense component is basically help us to provide a fallback component till the time our data get loaded. And so you can see here that I rendered my suspense component, and in my suspense component I have provided a source URL for the image, and I called a load image function. So which calls cache image function, which in turn returns a promise. So what happens is, in the first render, suppose that my data image data is not loaded. So what happens is it will throw the promise, which will be cached by the suspense block, and we'll see the loader for the time the data is not loaded. So data is in pending mode. So as soon as the data get loaded, we will render the my suspense image component. Let's see it in action. Here you can see the loaders for the small time. If I decrease the network condition over here, so here we are loading users. Then we see the loader for the image component. So here the image get loaded, and we'll see the result after that.
We have the code for that texture.
Yes.
Loading user example.
Okay, fine, I will show. So I have a list of threads which will be loaded by calling an API. So for that I have also an image component. Profile section user profile. Yeah. Here I have a user card component which will load the image. I have to provide the URL of the image, and on click, these are the attributes. So in my suspense image component, what happens is, here I firstly try to render the my suspense image component. This is a functional component. So I provide the URL and call the load image function. So in the load image function, which calls cache image function, here you can see that I am returning promise. And this promise, this function called create data source. So this is where the whole logic happens. This suspense with data fetching parts is happening. So what happened here is, this is the code to cache the data, so that we will not call the API again after some time. So here I said that if the status of the data is resolved, I will provide the value to the data, and this is the function. This is the read function which you see over here, which we call it over here. So what happens is, firstly I take the data in the result and check the status of the result. If the state of the result is pending, I throw the promise over. I store it in a suspender variable, I throw the promise. So actually if we throw anything in React or in JavaScript, it will become an error. So this is where the suspense component play an important role. So we do not have to handle it manually. So suspense component cache that promise, check that the type of the error is of promise, and if the error type is promise, it will show the fallback component for the time, and as soon as the data get resolved, it will render the my suspense image component over here. It will again render the my suspense image component with the data loaded. React also provide a different component which is known as suspense list. It helps us in deciding the loading states of our app. It helps us in deciding loading sequence. So we can decide which data we want to load first, then which data in a proper sequence. So you can see it in the example over here as you can see that first the image of the user get loaded, then user details are loaded, and after that the post get loaded. So we can control these things. So these all are coming from the API. So it may be possible that some of the data came first, and after that, after some point of time, other data came. But let's take the example. But suppose that suspense. Suppose the user posts come first. So we will see the user post in normal version of React, and after some time, we will see the user data with profile. So it will not good for a user experience. So in concurrent mode, we handle this problem by using suspense list. So what actually it does is, it is currently a wrapper around the suspense component which decide the reveal order of the closest suspense node below it. So let's see it with an example. So reveal order can be forwards, backwards, or together. So I have here I have shown you example of forward. So if we make it backwards, our data will start wait for the post to get loaded, then all the other data will be loaded. If we make it together, then all the data came together. So let's see, I will change it in the code. Okay. Suspense component extension, suspense list. Here I use the suspense list with reveal order is forward. Here I use another property which is tail. If I remove the tail property from here, and we can see that we will see all the loader at once. So we will see more than one loader at the same time. So I think it is not good for user experience. So we can handle this by using the tail property, which basically, if you set it to collapsed, we will see only one loader at a time. So if I change here the order to backwards, you will see it will wait for the post to get loaded first, then you will see the user data is loaded. So we can make loading sequence as we want. If I set it together, yeah. Fuck. I think this together is. No. So all the data came at once here. So you can play around with these, decide the proper loading sequence of that. So let's move with the presentation. So last thing that concurrent mode provides us is the new hook known as use transition hook. It helps us in making the transition smooth. So it basically what it provide us a way that the user will wait on the previous screen till the time the data is loaded for the next. Some of the data will get loaded on the previous screen, and after some time the user will move to the new screen and show the loaded data. So it basically return two values. First is start transition. It handles the state update we want to defer. So I will show you with the coding example. And second one is pending. So it tell that the update is going on. So it currently it help in solving the problem of flickering on transition and provide smooth transitions. So let's see it with the example of code. So you can see that the data, that user data is loaded over here. Then after some interval, we will see it over here. Okay. So let's see it once more. You will see the loader over here. So after that, the data will get after the data get loaded on the previous screen, we will transition to the new screen, and we will see the loaded data, and we can avoid the loaders which we will see for a small period of time. Let's see with the code how the code it work. Okay. Here I have a data property, data state, and I wrapped it. Here I have use transition hook, and use transition hook is basically, as I told, it has start transition function and is pending a boolean variable. So we have to provide a suspense configuration. So here I provided timeout of 3 seconds, 300 milliseconds, 3000 milliseconds, sorry. So what happened here is, so once I call on the any user data, user card. So I provided the call the set user data function, which contains start transition function, and which will wrap the set data, which will wrap the data state and load the data on the previous screen. So let's see if I set the timeout to around 100 milliseconds. 100 milliseconds, I set it to 100. Okay. And forwards. So you can see over here that as soon as click on the user, I transition to the new screen, and I will have to see the loaders over here. So if we have too many API calls in our screen, we will see too many loaders. So it is better that if we load some of the data which we show to the user previously on the screen, on the previous screen. So we can do this by using the use transition hook. Okay. So let's suppose 1000 seconds. I click on this user, it will start loading the data over here, and after some time it will transition to the new screen. So we can avoid the loaders by using use transition.
Can you show the code? Go back to the screen. Code. Like when I click on the user, on the right side, you're showing a loader.
Yes.
Can you show that code?
Okay, fine. I call the handle user data function ops. So here I have a user data component which has a function handle user data. So it will call the set user data function here, and after here I set the user ID, and after it will call start transition hook. So here what happens is, so it let me explain it with an example. So sorry, here you can see that this is the previous version of our tree. Okay, so as when we click on the user, React actually create a new copy of the previous memory and start rendering on it over the on the different branch, and we will provide timeout over here. So it will wait for the given timeout. So here say around I have provided 200 milliseconds. So it will wait for around 200 milliseconds on the previous screen, and till that time the spending variable get true, and as soon as the timeout is reached, we will merge both the branches together, and value of the spending become false. So here actually we will see the next screen with some data loaded, and we can avoid the loaders. Let's see the code. So here I call the start transition hook, which will wrap the set data, which will call the set data function from over here, which will update the data state of data. So here I call the load user ID function, and data will start loading for the given time of the suspense configuration. And here I provided the timeout over here, so it will wait for the data for the given time on the previous screen, and after that it will move to the next screen. So here I have also provided the value of is pending. So is pending will be true for as soon as the data is started to load it on the previous screen, and after some time it will get false. So we will move to the next screen. Like okay. Here I have checking that the value of the props that is pending, and I will show the loader for that time. Fine. As I have discussed this code already. So let's conclude what we discussed in the concurrent mode. So basically what concurrent mode provides is it makes the rendering non-blocking or interruptible. So we do not have to wait for the previous render to finish to start the new rendering. And second thing is we can handle multiple state updates with different priorities. So as you can see that we will, when a user click on any search bar, the React will suspend the previous render and give priority to the user input and any user actions. And firstly the React will do that action and then continue with the previous render. So we can also handle zeroing loading states using Suspense. So you have also seen that we don't have to write the code for handling the loading states in API calls. Suspense did it for us. And finally and last, we React. Basically, what happens when we do start data fetching with Suspense is we start rendering of the data even if it is not loaded. So at that moment, the component will throw an error in the form of promise. So other sibling components are not affected by it. So here in the example, I am trying to render this data before it came. So what happened here is it will not affect the image component and any other component and will throw us error. So Suspense will handle this for us, and we can, so basically React provides us the way, React concurrent mode provides us the way to handle the suspending state of the components without affecting the sibling components. Thank you. If you have any question, please.